Razcast here again, so let's jump into some practice questions on kinematics. So, by now you should have seen my previous video, or at least you should be comfortable with the idea that kinematics is about describing motion, and you can describe motion using words, using equations, using graphs. You should be fully comfortable with all of these concepts listed here. You should also be aware that there are 4 equations involving 5 kinematic variables, and that you can find any 2 if you have 3. Again, this is for a particular dimension. So this is if we are in Y, we need all of these to be in Y. The one variable that is not limited to a dimension, of course, is time. So if you identify those 3 variables, or in order to identify those 3 variables, you should look for clues in the question, and here are a couple of them that I went through previously. And then for representations of motion, you should be comfortable with the idea of slopes and areas, helping you to understand the relationships between these 3 types of graphs. Here are examples for constant velocity and acceleration. Now let's get into how the questions, or what the questions are going to focus on. The AP exam is big on this: qualitative and semi-quantitative analysis of representations. In fact, in a different location in the syllabus, they point out, instead of solving equations, students will use equations to support their reasoning and tighten their grasp of the laws of physics. It also mentions that these fundamental practices will spiral throughout the course and appear in multiple units. So what they're talking about here is the idea of qualitative, quantitative reasoning, or translation as it's sometimes called, and this is going to come up over and over in this course. So here's an example using kinematics, but I'm going to focus on the approach that can be applied to any unit. So here's the example. A child drops a ball from the 20th floor of a hotel. After 1 second, the ball has fallen 2 floors. How far will it have fallen after 3 seconds? This is a QQT, QQR question. The format of a QQR or QQT question is basically, if A changes in this way, or if B changes in this way, how will A change? If X changes in this way, how will Y change? So it's all about a relationship between an input and an output. This is the general approach that I suggest to my students. Number 1, identify what is your input, what is your output. Now in this case, time is our input. We had 1 second, it fell 2 floors. We have 3 seconds, it falls how many floors? So time is our input. Our output is how far it fell. Now in the context of this unit, we're thinking how far it fell is a displacement, is falling vertically. That's a vertical displacement. Delta Y is what we're looking for. Input and output, step 1. Step 2, identify all the other possible variables. We want to get a relationship linking our input to our output that has no other variables in it that will possibly be able to affect our output. This means any other variables in that equation should either be independent, meaning they have no effect on the output, or they should be the same in both scenarios. We have kinematics at play here, 5 variables involved, and we know one of them, which is time. So we need 3 variables in order to figure out anything. We have time, we need 2 others. The 3 options are final velocity, initial velocity, or acceleration, but our final velocity will change if our time changes because this thing is accelerating. So we cannot use final velocity. We want an equation that will involve time and, if anything else, initial velocity and acceleration, because our initial velocity is going to be the same in each case. It started from 0. And our acceleration, this is falling vertically, there's no other force on it, is going to be the same in each case. It's going to be acceleration due to gravity. Now, will that acceleration be positive g or negative g? Depends completely on what you choose as your positive direction. For the case of simplicity, I'm going to choose down as my positive direction. So it falls 2 floors. I'm going to call that a positive displacement of plus 2 floors. Now, third step, relevant equation. Once we've identified the variables, we can find an equation that links the input to the output and includes only variables that meet our constraints. This is the relevant equation, VO is 0, and so that when we simplify it becomes delta y is equal to 1/2 AT squared. Establishing the relationship, step 4. This is where once we have an equation with only our input output and other variables that are either 0 or constant or independent, we can simplify that relationship by dropping out all other variables and focusing on the relationship between the input and the output. In this case, delta y is proportional to t squared. Now we have to apply it. So this is how we apply this approach. We have our initial conditions. When t is 1, y is 2. We want to know what will delta y be when t is 3. There are at least 3 ways to look at this. The first one is in terms of algebra. You can always replace a proportionality symbol by an equal sign and a constant of proportionality. You can then use your initial conditions to solve for that constant. In this case, the constant will be 2. And then using that constant and the same relationship or equation now with that constant, delta y is equal to k times t squared in this case, you can plug in your final condition of t is equal to 3 and solve, and you get 18 floors. You could also do something similar by going back and using the equation with equal to 1/2 AT squared, and it will give you the same answer. Now, the second and preferred approach is to use the relationship. This is where you look directly at the factors that each side is multiplied by. So y being proportional to t squared means that whatever factor t is multiplied by, y will be multiplied by that factor squared. So our initial time was 1, our second time was 3. T2 in essence is 3 times T1. So what will delta y2 be? It will be that same factor squared times delta y1. And so when we do that, we realize we'd get y2 is going to be 9 times y1. y1 was 2. y2 will be 18. The third way of looking at this is really a visual representation of the second way. And this is by establishing a linear graph between the quantities involved. So this idea of linearizing graphs or linearizing relationships between quantities comes up a lot in AP Physics 1. And the idea here is that any type of relationship that you have between two variables can be manipulated and plotted in a way to yield a linear graph if you choose the right operations to do to each variable. What do I mean? I mean, if you plotted y versus t, you'd get a parabola. It's like a graph of y is equal to x squared. It goes like this. If you plot y versus t squared, you get a straight line. And again, you can plug in those initial conditions and extend the line and extrapolate from that the final conditions. You get the same idea of 18 floors after 3 seconds, because what you're plotting on the x-axis is not t, it's t squared. So 3 seconds means t squared would be 9. So here's an actual question from the AP exam 2015. Take a minute, pause the video and read it. So these two spheres leave the same height and travel over the same time, take the same amount of time to hit the floor, even though B was going initially horizontally. The first part, part A, asks about a free body diagram. We'll cover that in dynamics, but this is basically what it is. When they're in the air, they have the same exact force on them, especially because they are identical, so they have the same mass. The only force acting is the force of gravity straight down. If you are at all confused about how they can take the same time to hit the ground, remember that x and y are independent, so the velocity that B has in the x direction has zero effect on its movement in the y direction. And in the y direction, its initial velocity was actually 0 because it was moving horizontally, so no vertical velocity. In other words, its y motion is identical to that of A. And that's actually what part C asks us to answer. And I'll show you the marking scheme in a bit. On part B, they ask us to sketch and label a graph of the horizontal component of the velocity of sphere A and of sphere B as a function of time. Key point here, horizontal component, not vertical. Remember, X and Y are independent. So what's happening horizontally for A? Absolutely nothing. It's not moving at all. It has zero velocity for the entire time. And therefore, graph for A would be a straight line, horizontal at 0. A has 0 horizontal velocity for the entire time. Now what about B? B has a constant horizontal velocity. Its velocity is not changing. There is no force acting in the horizontal direction. So it has the same velocity it always had from the beginning. So let's assume that's a positive velocity. That's the only option they give us right now, after all. That's not going to change. So B would give us also a horizontal line because its velocity is not changing. That is B. A horizontal line but not at 0. So let's look at the actual scoring guidelines according to the AP. 7 points total, a single point for the Freebody diagrams. You have to indicate that the force represents gravity either by putting mg or fg, I assume. You should put them the same length. Once you have these horizontal lines here for Freebody diagram, that means they want you to indicate the magnitude by the length. A single point for this graph for both lines, and then the bulk of the points, 5 points, for the explanation. You need to indicate that the horizontal motion does not affect the vertical motion. You need to indicate that they both started with the same vertical velocity. You need to indicate that they have the same vertical acceleration and that therefore falling the same height would take the same amount of time. And as long as you put no incorrect or irrelevant statements, you get a point for that. So don't go rambling unnecessarily like I tend to sometimes. Just stick to the points. Main points. 7 points, 15 minutes. Quite easy if you know what you're doing. So this one from 2016 is a bit longer. Pause the video and read the question. So they're asking you to do two things. They're asking you to draw a sketch of the graph's actual velocity as it goes from bumps 41 to 44, and as well as drawing a dashed line for its average velocity. And it tells you draw a dashed horizontal line because it says that the average value becomes constant. Now I'd be inclined to do the second one first, and I would put just at any random point here, and I apologize for my lines, but that should be a horizontal line. That's going to be VAV. That's my average velocity. Now the question is, what are the velocities in between the humps going to do compared to that average velocity? So if we think about it, when it hits a hump, it's going to slow down. And in between that time and when it hits the other hump, it's going to speed up. Now the average velocity should be between those two. In fact, with respect to time, that average velocity should be directly halfway between those two. So from bump 41 to 42, I'd say it should look something like this. And then if we have the same average velocity for this section, then it should be repeated. So that's what the velocity will more or less look like. In between here, what happens? Well, it suddenly drops because it hits the hump. And so it doesn't stop moving, it just suddenly drops. So that should be like slightly slanted. So let's see what they were actually looking for. 3 points for this section. For having a constant upward slope in each segment. So each segment you should have a constant upward slope. Again, what's the key understanding here? That it's accelerating, and the acceleration on a VT graph, a constant acceleration, would be a straight upward sloping line. Constant positive acceleration if the velocity is also positive. For having the velocity reset abruptly. sawtooth function, not a sinusoidal curve, to a minimum positive value that is the same for each bump. So again, the idea that this average velocity being constant means that it should be halfway between that maximum and that minimum. It should come back to the same each time. And so for having the same minimum and the same maximum each time, you get those other 2 points. So now they ask, suppose the distance between the bumps is increased, but everything else remains the same. Is the maximum speed of the car now greater than, less than, or the same as it was before? So this is a spin on a QQT. Let's analyze it. So in this case, we want to know about the final speed. So our output is VF, and we've increased the distance between them. So that's delta X. Now, you might wonder, but it's going down a ramp. How is that delta X? I thought delta X is horizontal. Well, delta X depends on your frame of reference. And if something is traveling down a ramp, I would tend to take the down direction of the ramp to be my X direction, and the perpendicular to the ramp would be my Y direction. But we'll get to that when we do dynamics. So we want VF if we change our delta X. What are the other possible variables? Kinematics, we have 5 variables. The others are these 3. So what are the relevant equations? Well, out of those other variables, what do we know? If it's the same angle, then we should have the same acceleration, because acceleration is based only on the angle. And we'll prove in Unit 2 dynamics how this would be g sine theta for a ramp without friction. The initial velocity, let's assume it was from rest. What about time? Well, if we have more distance, in fact, so we're not sure about time, ideally I would say we should leave it out. So let's look for an equation that has VO, A, X, and VF. I find that equation right here. So if we look at the relationship between delta X and our final velocity, if we have the same acceleration and if this initial velocity is 0, that breaks down to our V final squared is proportional to our delta X. And so all they're asking is, will this go up or not? Well, if delta X goes up, this will go up. So that's true. Now, how will it go up? Well, this is interesting. This is a little different to the one before. Now, our output, which is V squared, is related to, now our output squared is related to our input. So if we wanted to make V the subject there, we'd say V is proportional to, we'd have to square root both sides. V is proportional to the square root of delta X. And what that means is that we'd have to multiply delta X by 4 in order to get our final V to double. Now you can also look at it in terms of time by using this relationship, but I would suggest that if you wanted to use time, you'd have to justify why time and how time would increase with an increase in X, and that would be using this relationship here. So similar to what we did before, the relationship between time and our X, assuming our VO is 0, would be that time squared is proportional to X. So again, we get time is actually proportional to the square root of X. And then from this equation here, we get that our final velocity is proportional to time, and time is proportional to the square root of X. So we come back to this same relationship here. A little bit of a roundabout way, but you get the same thing. Now, for this question, they only asked you to choose greater than, less than, or the same as, and to explain your reasoning. And so we didn't even need that relationship. For the other one, they asked what if the ramp angle were tilted, and if the ramp angle were tilted, then we could assume that the acceleration would increase. And so the acceleration increased by either one of these two, but I would suggest best to use this equation to say that if the acceleration increased for the same spacing, the final velocity would definitely go up. In fact, it would go up again by a square root factor. Now, if we look at what the scoring guideline said, The answer is greater than, but you get no points, even if you have the correct answer, if your explanation is off or if you have no explanation. And you get no points for the wrong answer. So you can indicate either that there's more time or that there's more distance to accelerate. The maximum speed is greater because the car has more space or time to accelerate, build up speed between bumps. Or you could look at it in terms of energy, and energy is always a good fallback. For the other one, again, greater than is the answer, and the main idea here is that the acceleration is greater, and they ask you to explain it in terms of the component of the gravitational force, which we'll come to in dynamics. Now part D gets into experimental skills, and so take a moment to read the question and then come back. So an equation is provided for V average, data is provided, and you are asked whether the data is consistent with the equation. Now this was a bit tricky. If we analyze the equation, we see that V average and M are directly proportional, and if we look at the graph, we see that V average increases as M increases. However, is it a direct proportion? It seems to be a linear relationship, but it doesn't intersect at 0, 0, which means that direct proportion without some added constant on the end here would suggest that when V average is 0, or when M is 0, V average would be 0, and when M doubles, V average would double. When M is 0, it does not appear that V average would be 0, and when M doubles from 1 to 2, the value does not double. It goes from about 1.5 to about 2. So the answer would be no with that explanation. Now that said, you do get 1 point out of 2 if yes is selected, if you explain that V average increases with M. However, they wanted you to say that either the y-intercept is not 0 or that it doesn't double as it should. V average doesn't double when mass is doubled. In the next part, they tell us that another student suggests that the equation may not make sense for other reasons. So let's look at the equation. So ignoring the M for a while, because we're not sure how it should vary with M, V average is proportional to G sine theta. So that means that if you have a bigger value of G, you'll have a bigger average velocity. Makes sense. More gravity will pull it down faster. If you have a bigger sine theta, which means you have a steeper angle, you should have a bigger V average. That makes sense. But over D, that says that V average is inversely proportional to the distance between the humps. So that's saying that if you have a bigger distance between the humps, your average velocity is going to decrease. That is completely inconsistent with what we said in the first part and doesn't seem to make any physical sense. So according to the scoring guidelines, the answer is no, and you get 1 point for saying the correct answer, but the other point for the explanation, and again for implying that there's a contradiction between the reasoning in part B, or for stating that a bigger distance leads to a larger maximum average speed, showing that the equation doesn't make sense. That will give you a second point. However, you would get 1 point even if you got it wrong if your reasoning was legitimate. In other words, saying that increasing the angle will increase the V average, then you will get 1 point. So I hope that was helpful. Look out for more videos, and remember kids, physics is fun.